So in the last video, we took a look at implementing the event handler with an anonymous inner class. So we did that for both the previous button's event handler and the next button's event handler. And now what I want to go ahead and do is also demonstrate this using what are known as Lambda expressions. So I'm going to go ahead and take away all the code that is inside of my setOnAction for my previous button. I'm just going to go ahead and delete that. And I'm going to replace this with just a very short and simple line of code that essentially captures the exact same behavior as the anonymous inner class. And the way this is going to work is that I'm going to provide the name of the parameter for this handle method, this event that I have right here. So I'm going to provide that event. And then include this arrow notation. So it's going to be the essentially the hyphen and then this less than symbol. And then I'm going to provide the code that I would put into the body of this handle method. So in this case, that'll be this single line of code right here. But in this case, it's going to be for image1. So we're going to do iv.setImage and image1. Okay. So this single line of code, what I've provided right here, this is going to capture exactly the same behavior as this entire anonymous inner class that I used before. So then I'm going to go ahead and do the same thing right here. Just go ahead and delete that. We'll put our event, put our arrow notation, and then put iv.setImage. This will be image2. So we'll go ahead and save that. And then I can go ahead and compile this and run it, and it'll still work exactly the same as it did before. So we'll go ahead and come back to this line for compiling, and then run it. And then we'll see our interface is still the same. I click next image, it navigates to the next image. I click previous image, it navigates back to the previous image. So everything still works just the same. So take a quick moment to look over this and explain exactly what's going on here. So the reason that this Lambda expression works the way that it does, I mentioned before that the event handler, this piece that I'm importing right here, that this isn't actually a class, it is instead an interface that I'm getting from Java. And the reason that I'm able to do this functional interface to implement this interface is because of the fact that event handler, more precisely, is going to be what is known as a functional interface. So this is just a really convenient way to write this very compact, this short line of code where the handle method is the only method that I actually need to implement within that event handler interface. So because of that, I can just specify the name of the parameters that I'm going to be using for that, that handle method. And then using this arrow notation, it's essentially the divider between the parameters and the actual body of code for the handle method. And then I'm just going to provide this single line that essentially defines what it is that this handle method is going to do. So I'm doing that for both the previous button and the next button. In each of these two cases, I'm just creating or I'm implementing this event handler interface with a slight variation on that implementation. And then one additional thing that I want to go ahead and demonstrate with this, something that's very unique about Lambda expressions, is you'll notice that with the way that I've set this up, I never explicitly provide the name of event handler or action event anymore. I'm going to go ahead and just remove both of these imports. Just save that. And so the expectation here is because of the fact that I'm implementing the event handler class and I precisely want to be using an action event, that's what this event right here is supposed to be, there's this expectation that I would still need to import both of those classes so that my program can understand exactly what's happening with this Lambda expression. I'm going to go ahead and compile this. And we'll see that when I compile this, it doesn't actually give me any errors or any warnings about, say, perhaps a symbol that it doesn't recognize. So it seems that my program is able to easily recognize what I mean when I use this Lambda expression without me explicitly trying to import either of those two, that interface and that class. And the reason that it's able to do that, as I mentioned back at the start of this discussion about JavaFX, I made a note about the fact that I wanted to always be very explicit about how I'm importing certain classes into my programs. And I made a note about the fact that the reason that I do that is not because of this concern about code bloat, which is to say that if I just did a single wildcard import, it would just bring in everything and it would make my code overwhelmingly large. There's no issue like that with Java because of the fact that we always have access to that Java API. So everything's just always there at all times, and it doesn't really have any impact on the size of your code. It was really just an impact on your naming conventions. So because of that, that means that regardless of whether or not I do these imports, that code from that API is always there. I just have to do the imports to make sure that whenever I want to use one of these names in my program, the Java is able to immediately recognize what that name actually means. That's the purpose of the import statements. But in this particular case with this Lambda expression, the way that I've written this, because this Lambda expression is meant to implement a functional interface, and because of the context in which I'm using it, that is to say for the setOnAction method, there is only one possible interface that this could possibly be referring to, and there's only one type of event that this could also be used with. So because of that, my program is able to implicitly determine exactly which interface and which class it needs to bring in to actually handle this, the implementation for this Lambda expression. So I'm able to remove the import statements because of the fact that it can implicitly determine exactly what's going on lines 33 and 35 of this program. So just one additional fairly interesting point that I wanted to make about Lambda expressions. Eventually, in a later chapter, I'll go into more detail about exactly what Lambda expressions do, a few other syntactical concerns that you want to take into consideration about them. I'll do the same for anonymous inner classes as well. For now, I just wanted to do a quick demo of using both of these programming structures, these anonymous inner classes and Lambda expressions, in event handling for our JavaFX applications. In the next video, I want to go ahead and do a quick summary about different use cases or different concerns you want to be able to take into consideration when it comes to deciding if you want to implement your event handler using a private inner class, an anonymous inner class, or a Lambda expression. So we're going to take a look at the pros and cons of each of those three different approaches we could take.